because we are keen to move on. We have our International Advisory Board, which Fabian is attending on behalf of the IEA later this afternoon. For many of us, then we don't need to introduce Fabian. It's like having a member of the family back for Christmas, but without the usual arguments that families have. Fabian was, I believe, the first graduate of our PhD program, and has since gone on to be an energy analyst. Is your official title?
No, that's fine, energy analyst.
Yep. Yeah. For the International Energy Agency in Paris, where he is a key member of the team that has produced the World Energy Outlook. The IAWEO is one of the key authoritative forecasts and analyses of the global energy industry. And because it is so well known, it attracts a lot of attention, and I'm sure we'll have a whole bunch of questions for Fabian. Fabian was going to speak for about half an hour, so perhaps clarifying questions only, and we'll let you get through it, and then we'll open up to a good question and answer session. But Fabian, please.
Thanks a lot. Thanks a lot for the kind words, Neil. Yeah, as Neil said, I'm working at the International Energy Agency. It's now more or less about exactly 2 years ago that I defended my PhD in the room over there. So what I'm going to present to you in the next 30 minutes, it's the main findings of the World Energy Outlook that was released about a month ago in November. So I think Fatih Birol is coming over to London in March to present it. If you want to see the same slides again, go there. If not, you don't have to. Yeah, let me spend first a few instances on how we see the world energy scene today and what are the biggest trends. We see that there are quite a few things in the world energy system that are changing. Some countries' job definition are changing. Countries are turning from being importers to exporters, with the main example certainly being the United States in terms of natural gas, as only a few years ago LNG terminals were built in order to import gas, but that actually never materialized, and now a few terminals have been approved to export natural gas, and we expect to see some amount of exports in the near future. But also other countries, such as, for example, Brazil, is turning from an importer to an exporter. We expect quite a bit of oil exports coming from Brazil in the next years, and I will discuss this in a bit more detail on another slide. On the other hand, exporters are becoming major sources of demand. Here, particularly the Middle East, we still see persistent high levels of fossil fuel subsidies that are keeping energy prices artificially low and thereby being major hurdles to the deployment of energy efficiency, so that energy demand for oil and gas, but also for other sources, is to Asian countries for its exports. Now, I said that there are a few things being rewritten in the energy system, others are more or less staying the same. This concerns CO2 emissions. Now, we have seen quite a bit of a push in the direction of energy efficiency, which is expected to play out in the future years. For example, in the United States with the fuel efficiency standards, in Europe, the EU Energy Efficiency Directive that is going to be implemented by the member states the latest next year, but also in China, which has done quite a lot in terms of industrial energy efficiency. But we see CO2 emissions rising. They have reached a new record high last year, 31.5 gigatons CO2, and such a trend is certainly not compatible with a 2-degree trajectory. On the other hand, I mentioned that before, fossil fuel subsidies, they remain very high. They have crossed $500 billion in 2012, particularly driven by countries in the Middle East and North Africa, so that oil demand is growing ever faster. And lastly, we still see some symptoms of the energy system that are almost the same as in the past. 1 in 5 people lack access to electricity, and about 2 in 5 people lack access to clean cooking facilities. This is mainly located in countries of sub-Saharan Africa, but also Pakistan, Bangladesh, or India, and this is significantly negative health impacts due to indoor air pollution, particularly for women and children. Now, energy prices are also very important for policymakers and decision makers in the energy system. We just think back, many people think about the oil price as in 2008 at around $150 in the peak. But what we've seen over the last 3 years is that oil prices on average have been over $100. This is unprecedented in history, and we will see what this will mean for competitiveness, but also for the energy system becoming more efficient in the next years. On the other hand, over the last few years, we have seen energy prices, especially for gas and electricity, diverging in different economies, and I will discuss a bit later what this means for the economy. Now, let's turn to energy demand. If we look at the past or the present, energy demand growth has come from OECD countries, with major centers being the United States and Europe. But if we look into the future, we see that out for the next 22 years, there's almost no growth in terms of energy coming from OECD countries. It's only 4%, driven by the fact that OECD economies have become more efficient, energy growth has de-linked from economic growth, and there is a certain saturation level reached in those economies. So if it's not the OECD economies that are driving the growth for energy demand, where is it coming from? Now, this is not coming as a big surprise. It is Southeast Asia, India, and China, so non-OECD countries in Asia, particularly driven by China in this decade. Strong growth coming from there. But this is leveling off in the later period of our projection from 2020, 2025 onwards, as the economy is more and more linking from energy growth, a saturation level sets in, and certainly efficiency policies that are relatively important in China. So it is India that is going to overtake China as the single largest source of demand for gas, but also Southeast Asian economies are coming into the picture, so that the center of gravity is really shifting over to Asia. Now, I mentioned the Middle East. Middle East is becoming a major center of demand. We expect the Middle East to consume about 10 million barrels a day in 2035. That is the amount that China is currently consuming. I said that the energy system is more shifting to Asia, so the regional composition of energy demand is changing, but the composition in terms of fuels is not really changing. We have seen over the past 23, 24 years that it was actually fossil fuels that satisfied most of the increasing demand for energy. Particularly coal was the largest source that satisfied this growth, and the share of fossil fuels remained the same over the past 25 years at more than 80%. So despite the push for renewable energies in Europe or in other regions, this share remained the same, and it might have been higher had we seen this push for renewable energy. If we look out into the future, yes, renewable energy sources and nuclear power, so-called low carbon sources, will satisfy quite a bit of the growing energy demand. It's about 40%, but still we will see quite a bit of this being satisfied by fossil fuels, with natural gas taking the largest share, as it is the cleanest fossil fuel. I mentioned CO2 emissions on the first slide. If we look at the past and see how cumulative energy related CO2 emissions evolve, we see that the major share of CO2 emissions came from OECD countries, but this is now shifting when non-OECD countries are taking on a bigger share, and going into the future we see that taken all emissions from 1900 as a cumulative total, about half of that will come from non-OECD in 2035 and half from OECD. However, we should certainly point out that per capita emissions in the non-OECD countries are staying far lower than in the OECD countries. However, there are certain regions such as the Middle East or China, which on a per capita level we see overtaking the European Union. And just to complete this is putting us, in our estimate, on a pathway to about 3.6 degrees Celsius temperature increase. It's certainly not compatible with the 2-degree goal of the UNFCCC, and this would just mean more storms, more floods, and more extreme temperature events. Each year in the World Energy Outlook we have a focus on fuel, and this year's focus is on oil. So let me first start by looking at oil demand. The growth for oil demand is not coming from OECD countries. We actually see a decline here, driven by the fact that we see saturation levels coming in and fuel efficiency standards in the United States, in Europe, but also Japan, playing a significant role in pushing down the demand for crude oil. Now, if the demand is not coming from the OECD, it's coming from Southeast Asia, but also the Middle East, where we see an increasing demand from the transport sector, but also from industry, so that we reach a level of about 101 million barrels a day in our central scenario in 2035. Now, if we look at the different sectors, we see that the transport sector is responsible for the bulk of the increase in oil demand. It's about 10 million barrels, but contrary to the common belief, it's actually not gasoline, so the fuel that is used primarily for personal light-duty vehicles, but it is driven by freight traffic. Why is it freight? Just because there is an ever-increasing demand and fuel efficiency standards for trucks are not existing or not as stringent as for cars. So that about 1/3 of the increase in oil demand from the transport sector is coming only from trucks in Asia. Now we see that there is also another driver, it's petrochemicals. The increasing demand for plastics is increasing the demand from this sector, while other sectors see a decrease, particularly the power sector, where it is more economical to use natural gas instead of burning crude oil or oil products. We have also dedicated our analysis to the interlink between oil demand and oil supply, which is the refinery sector. If we look at the refinery sector, we see that actually an ever-increasing share of crude oil is bypassing the refinery system. Not all crude oil is going through refineries, be it natural gas liquids, which are being fractionated into ethane, LPG, or naphtha, and being directly used, for example, by the petrochemical industry, or there's on-purpose production from coal to liquids, or natural gas to liquids, which is also not entering the refinery system. So if we see what capacity we have currently, we see that it would be actually enough to satisfy all the demand which we see in 2035. So we wouldn't need any additions of capacity to satisfy the market. Now, certainly this might not be in the locations where you have the demand, and that is why we are expecting to see new refinery capacity being added, particularly close to demand centers, as it has been historically the case. So as the demand is coming from China, India, and the Middle East, that's where we expect the refinery capacity to be built. But this isn't actually good news for refineries in OECD countries, and particularly in Europe, where we see some spare capacity and the risk of closure of up to 10 million barrels a day of refinery capacity. Now, let's quickly turn to oil production. we actually see two chapters here. In the short term, we see an increase, the short term, I would rather say medium term to 2025, so that's still the next 10, 12 years. We see quite a bit of the increase in oil production coming particularly from Brazil, but also the United States in the form of unconventional oil, light tight oil, but also the Middle East, particularly Iraq, who's going to increase its production significantly. But if we look into the longer term, out to 2035, our projection horizon, we see that the oil production in the United States, thanks to unconventional oil, is actually plateauing in the 2020s and then declining slightly as the resource base is limited. So the call in the longer term is really on the Middle East, Saudi Arabia, Iraq, and other countries, and investments need to happen now in order to satisfy the demand, as it takes quite a few years, up to 10 years, to bring the oil to the market. Now, I mentioned Brazil on the first slide. Brazil is this year the country of focus. Every year we have a country that we focus on. Last year it was Iraq, and this year we focused on Brazil. Brazil is an interesting case, as it is expected to export more and more oil. Most of the oil findings, the really big oil findings in oil fields, have actually come from Brazil over the last few years. This is mainly offshore, off the coast of Rio de Janeiro, where we expect that oil production is going to increase to around about 6 million barrels, with a lot of that being exported. On the other hand, Brazil is facing quite a few challenges in terms of electricity. We expect that the electric capacity needs to double, which means about adding 6 gigawatts of electric capacity each year, or 6 nuclear power plants, which is not easy in such a big country, which needs a lot of transmission and distribution lines, but we nevertheless expect most of this to come from hydro, mainly runoff hydropower plants, so that the electricity mix in Brazil will stay very much focused on renewable energy, in contrast to the global mix, where fossil fuel sources dominate the electricity mix. Now, power generation, where is the capacity actually being needed to be installed? We see this is mainly driven by China, where the energy demand is increasing, but also India, and to some extent the United States and Europe. But the interesting bit here is really to see how much of these new capacities are only replacing older facilities that are going off the grid. And here we see that the average age of fossil fuel power plants in OECD countries is much older than in non-OECD countries, where we have about 2/3 of coal-fired power plants that are younger than 20 years, so that about 60% of the capacity additions in OECD countries are merely replacing existing capacity. If we look particularly into renewables, we see that there is one country dominating the additions in renewable energy sources, and this is China. China is going to add more than the United States, Japan, and the European Union combined, with some other countries such as India, but also Latin America being responsible for the rest of the additions. Now, if we look particularly into the energy sources which are concerned by those renewables, we see that in the developed world, Europe, Japan, United States, it's mainly solar PV and wind power, but in China or in Latin America and other Asian countries, hydropower plays a very important role, as I've just mentioned for Brazil, where we expect the majority of the capacity additions to come from hydro. It is similar in other regions, with wind power and solar taking up the rest. This will only be sustained by subsidies, where we see that currently renewable subsidies reach about $100 billion. Just to put it in context, I mentioned the number for fossil fuel subsidies before. This was close to 600 billion. So renewable subsidies make out only a sixth. To put it in context, now where are most of the subsidies coming from? It's the European Union. No big surprise here, as the European Union was one of the first regions to move into that direction, with the rest coming mainly from the United States and other emerging economies. And we expect, in order to meet the renewable energy growth, that subsidies will about double out to 2035. Now, let me turn to a focus that we had this year on competitiveness and energy prices. If we look back into 2003 and look at the natural gas prices across the different regions, we see that compared to the United States, they were more or less the same in the European Union, slightly cheaper in China, and about 1.5 times more expensive in Japan. But this was about 10 years ago. Now, if we move on to the present, we see that natural gas prices have diverged significantly. The United States, due to the shale gas revolution, unconventional gas production, has pushed down gas prices to around $34 per MMBtu. And in Japan and Europe, but also in China, gas prices are staying higher. In Japan, they're almost 5 times higher. In the European Union, almost 3 times. And in China, more than twice as expensive. The important message, however, is that we expect those differences to persist. They are not going away in the future. No, they are being diminished, but natural gas will still be twice as expensive in the European Union over the next 20 years, or in Japan, compared to the United States. Now, what does this mean for electricity? Natural gas prices have some influence on electricity prices. If we look at electricity prices again here 10 years ago, yes, there was some variation, but it wasn't very large, except for Japan, which had seen more than twice as expensive electricity prices than the United States. We see electricity prices in Japan coming down a bit due to the fact that we expect nuclear power to be restarted in this country, but electricity prices are going to stay more or less the same compared to the United States and the European Union, but also in China they're staying higher due to the fact that there is no access to cheap gas, and certainly also driven by the fact that there is a CO2 policy in terms of CO2 prices being higher and renewable subsidies. So what do those differences in electricity and gas prices mean for the economy? And here we particularly focus on energy-intensive industries. Now, if we look at all industries, there are only a few where energy costs matter for more than 10% of production costs. But there are the energy-intensive industries, and if we look at them, for example, the petrochemicals, so plastic production or fertilizers, aluminium, cement, their energy costs matter a lot, up to 70–80% in petrochemicals, but even around 40% in aluminium. And we shouldn't forget that they are still representing about 1/5 of industrial value added, about 1/4 of industrial employment, and 70% of industrial energy use. So what we analyzed was the export markets in those goods, mainly chemicals, but also steel, aluminium, and so on. And we see that currently the European Union is by far the largest exporter of energy-intensive goods. But what we were interested in was how is this going to change in the future? Now, emerging economies are gaining export market share driven by domestic demand that is more and more requiring capacity, which then alongside enables exports to other countries. But the United States, given their advantage in terms of cheaper electricity but also natural gas prices, sees its export share increasing, to the very contrast of the European Union and Japan, where the export market share is going to decline as a result of high energy prices, certainly driven also by other factors, but energy prices play a role here, so that those industries have to see how to face high energy prices, for example, by looking more into energy efficiency or changing natural gas prices away from oil indexation. As we are in the European Union, just one good news, the European Union still stays the largest energy exporter, combining more than the 3 largest exporters, afterwards the United States, Japan and China. Now, second to last slide. I've talked about the advantage that the US is enjoying in terms of natural gas prices, so the obvious question is, can't the other regions, particularly Europe or Japan, profit from so low energy prices? If we look at the natural gas price, currently it's about 4.3, I think, dollars per MBTU in the United States, and it is much higher in Asia Pacific, particularly Japan, over $15 per MBTU, and about 10, 11 in the European Union. Now, the decisive factor here is that it always costs quite a lot of money to export natural gas to other markets. You have to build very capital-intensive LNG plants and transport the gas, which represents about $6 per MBTU. So even if export terminals are built in the future, you will always see a persistent difference between those countries that are enjoying cheap gas, such as the United States, and those that rely on imports. However, as we see in the shaded area, there is certainly some room to bring down natural gas prices and align the markets more, but we shouldn't believe that there will be a homogeneous price in all regions. Now, let me quickly summarize what I said. We certainly see the energy system shifting over to Asian markets, particularly China, but in the future, over the next 10, 20 years, also other Asian economies with implications for trade. On the other hand, the shale revolution, but also light tight oil in the United States has very significantly affected the global energy system with new export routes emerging, and on the other hand, major importers growing, particularly in the Middle East, with persisting high fossil fuel subsidies. Lastly, competitiveness is a headache, particularly in the European Union, but also in Japan, where energy-intensive industries are facing a lot of competition with the United States. So then we need to find ways in order to address this concern with energy efficiency, particularly the first to be in line, as high energy prices do not need to translate directly into high energy costs if you're more efficient. But there are also other ways, for example, shifting away natural gas pricing from oil indexation. And then lastly, it is still of utmost importance to achieve an efficient and low-carb energy system, although it is certainly more difficult to do so in financially troubled times. But the urgency is still there, and we all have high hopes for the UNFCCC meeting in Paris in 2 years. So thanks a lot for your attention, and if you have any questions, please feel free to ask them.
Thank you, Fabian, for a tour de force of the IA's WO. I mean, clearly you have someone in the IA who does your slides for you now. Those slides were fantastic. We'll open up for questions now. I just wanted to abuse my position as chair and ask you one first. You presented just one scenario. Could you talk a little bit about some of the key uncertainties the IA are focused on, and maybe some alternate views of the future that you may have thought through?
Sure. So as Neil rightly pointed out, I just focused on our central scenario, which we call the new policy scenario, but the energy world is very uncertain. Certainly a key driver here is economic assumptions about GDP growth, which can certainly affect future supply, but also demand. But a major factor for us is also policies. Policies are intrinsically uncertain. You don't know what certain countries are going to implement, and that is why we differentiate those, which will then certainly lead to different energy demands in terms of absolute level, but also the energy mix. And we focus on, we also present normally a 2-degree trajectory scenario, which we call the 450 scenario. I haven't talked about this in the presentation this year because earlier we had a focus on climate change, where we presented a scenario that was pointing out 4 easy measures about how to reduce CO2 emissions in the short term, and this is certainly something which would radically change the energy picture.
Thank you. Shall we open up for questions? Gabriel first and then Alex second.
Okay, thanks, Fabian. For this recent near-term increase in oil production for Middle East, we focused on Iran, if near-term production. Because of the recent changes in Iranian politics, and if they are allowed to kind of completely export it, go into international market, and if they increase their production in the near term, would it somehow affect your projection here?
The thing that we have to see with Iran, there's still quite a bit of uncertainty around there. So this will not go away very easily until you get the expertise into the country. We certainly see an upside potential here if sanctions are lifted in the long term and a more stable investment background comes in. But we don't expect, even if all the sanctions are lifted, that this will have a major impact on oil markets. This will certainly increase the oil supply from Iran, but only to a limited amount, and will not be enough to replace the major oil producers' growth, such as Iraq or Saudi Arabia.
Yeah, I was about to ask the same question, similar, but I was wondering whether you included Iran at all to your oil market scenario in the Middle East. And second question would be on the Australia, because they are recently eliminating their carbon cap. So what does IEA think about the impact to the energy market in general?
So I think, yes, so we focus on each country, so Iran is taken into account, and actually we have, our production process is quite long, so when we finish our writing, this is already in September, I would say, October, and I think the meeting came a bit later in November, so this was not factored in here, but as I said, even if we do that, and certainly next year we will do, this will not have a major impact on global oil markets. Yes, the government has changed in Australia, and the government that is now in place has announced to scrap the CO2 tax. I think this hasn't yet happened due to some legislative problems. This is certainly a move which we don't really welcome, as a carbon price is one of the best signals to encourage low carbon growth and also more efficient growth. But we have to see this in the wider context, and there the impact is going to be limited just to the mere fact that Australia is not a major energy demand center in the world.
Thank you. And from memory, Europe has about 40% of the energy-intensive industry market, but at least in terms of exports. At the same time, we also have a much higher energy price, and that is, I wonder if you could elaborate on that. And I was also surprised because actually kind of the energy as a part of the total cost seems quite a high share. We are looking at a kind of 60%, and I suppose some role that there is in different energy efficiency across countries, but I wonder if there is other factors explaining this counterintuitive position.
True. That we see a range of energy costs?
No, the fact that, I mean, the energy price is very high in Europe, and still we seem to have and you would expect therefore not to be producing very energy intensive goods.
Mm-hmm. The thing behind that is that this is a very recent evolvement. So only a few years back, as I have shown on the slide, energy prices were more or less in line across the major regions in OECD countries. So this is a recent phenomenon, and those developments take time to implement. Now, certainly there are factors that limit such a reversal. There can be quality advantages in Europe or in Japan that prevent some energy-intensive industries from moving abroad. There can be integration, for example, with refineries and petrochemicals. There is a lot of integration of those two complexes, particularly in Europe, which helps them to drive down costs, efficiency. Normally, those energy-intensive industries are much more efficient in Japan and in Europe compared to the United States. So this is all helping. But certainly we need to face it in the future, particularly in those industries where energy costs account for a lot, such as petrochemicals, there is a lot of pressure on industries. We have seen this in the UK here. INEOS wanted to change the refinery or petrochemical plant in Grangemouth in Scotland, and they have finally only retracted from that because now they're going to import ethane from the United States. But the situation for those industries is certainly not rosy, particularly in the United States, in the European Union.
Other questions?
To follow on from that, when you're making estimates of excuse me, the way that these industries will be moving away from Europe, how are you categorizing the ones that you think will shift? I mean, is there a score in terms of capital mobility? Is there something involved in is it just simply on energy intensity of the actual industry? How are you categorizing those?
What's the methodology?
Yeah, exactly. Yeah.
So what we're doing is normally for our World Energy Outlook we use a bottom-up and energy sector model, but for this analysis we actually used a CGE model, computational general equilibrium model, from the OECD, so that we linked our two scenarios, and our colleagues from the OECD came up with the analysis and helped us to do so. So where they look really into what are the capital costs, what are the labor costs, what are trade costs in place, and this is how we derived those numbers.
But there's no estimate in terms of the inherent mobility of a type of industry or anything like that. So the idea that capital may be more mobile in one industry, for example, I don't know, it depends on local skills, things like that. Is that taken into consideration at all in this?
This is taken into account in the modeling in terms of barriers and limitations, but certainly you can't take into account every special factor. But it's certainly taking into account that some companies from Europe can invest in the United States in order to profit from cheaper energy prices.
Steve?
I was quite interested in your fossil fuel subsidy number, which is very large, of course. Just wondered if you've done any analysis where you've removed those subsidies and looked at the impact on demand, and whether that has a sizable impact globally, or whether it's more focused in those regions where subsidies are most prevalent. I think you mentioned Middle East.
Yeah. So we haven't done a particular scenario where we looked at what happens if we remove all of those subsidies. Now, what we assume in our scenarios is that if there are policies announced to reduce subsidies, we implement that. There are quite a few countries that have moved forward and tackled this issue, Indonesia or Iran, for example, that have done quite a bit. And in our new policy scenario, our central scenario, we assume that in all major importing countries, subsidies are being phased out within the next 10 years. This particularly affects China and India, where we still see some subsidies in a few sectors. Now, we would judge it very unlikely that we see very soon a complete removal of subsidies. So even in our most stringent scenario, the 2-degree scenario, we don't assume that subsidies in the Middle East will be completely phased out. There will be a gradual phase out, as you would face social problems if you do this more quickly. This certainly has an impact on demand, but the energy demand in those countries is not accounting for a huge share of worldwide demand. So there will be certainly an impact, but to what extent we haven't really focused on it.
So I have Gabriel and Paolo on standby. Anyone who hasn't asked a question would like to? No. So Gabriel first, then Paolo second.
Okay, thanks, Ian. So you may have already explained it, but currently, as you said, there's a big difference in natural gas prices between Japan, China, Europe, and USA. But in the projection, you showed a future reduction in gas price in Japan, because currently it is driven by higher demand and higher energy transportation costs. Actually, what drives this reduction in the future for the gas price in Japan?
What is driving that? There are two factors. First of all, there is demand, which we expect to decrease slightly as we see more nuclear power plants taking over its share in the electricity mix. So there will be less of a need to import natural gas. And on the other hand, we expect that there will be more competition in natural gas trade, particularly from the United States, that will be expected to export some of the natural gas, which will drive down import costs. So this is actually two factors.
they're playing.
Very, very similar to this one actually. If you could elaborate on why you still see a kind of a difference in terms of geographical prices, in particularly referred to LNG, to natural gas, therefore LNG, but also if you can see the same happening in terms of oil, for example, between an NYMEX, between the WTI and the Brent.
I mean, if we look at current crude oil prices, they're certainly not perfectly aligned, but they differ by a few percentages. And now we have a particular situation with the WTI, which will be potentially resolved in the near future. That's why we've seen some differences here in crude oil prices, but normally they're relatively well aligned. Obviously, there are some differences accounting for crude oil qualities. For natural gas, that's a different picture because it's not a global market. Natural gas is a regional market. Simply due to the fact that if you transport natural gas, you can only transport it in a liquefied way, and here we estimate that transportation costs are around about $6, for example, from the United States to Europe or to Japan, which mean that if you have natural gas prices in the US of $4 per MBTU, this will still mean that you would have $10 in Japan if you only account for transport costs, and this is preventing the establishment of a global market with the same natural gas prices everywhere.
So then, let me ask you a final question. You focus on Brazil in this WEO, and you had all these projections as to its growth and how many gigawatts of electricity it's going to add. I realize you need to be diplomatic at the IEA, but it seems to me that Brazil can't even build a football stadium at the moment. So do you actually believe that they're going to do this massive capital investment over the next 2 decades?
There are certainly factors that you have to consider. The main problem in Brazil is the geographical space that you have. So there needs to be a lot of transmission distribution lines being built, which is certainly tricky. And the main obstacle or the main challenge for Brazil is will they be able to add so much hydropower in the future? As there is local resistance, particularly in the Amazon, where most of the hydro resources lie. That's why for example, we assume that there will be most of this hydro power coming from runoff river, not from hydro dams. But we have also run a scenario where we say, okay, what happens if there is a restriction on hydropower? And then it will be other fuels making up for the electricity. However, we still see that there is quite a significant growth for energy as the economy in Brazil is increasing. And actually, we got the very opposite commentary from our Brazilian partners, which said that you're completely underestimating the energy growth in Brazil, as this will be still very closely linked to economic growth.
Well, with that, please join me in thanking Fabian for his presentation. And if you have any other questions for Fabian, then we'll let him take his microphone off and stop filming it.